Hi everyone, this is Veda Vidhya from CSC department working as assistant professor in MLR IT. So today we are going to teach a subject data structures. So coming to the data structures, our first unit is Introduction to Data Structures. So this is our unit 1 syllabus, what we are going to have: Introduction to Data Structures, abstract data types, and here we are going to discuss mainly two data structures, that is stack ADT and stack operations, implementing stack using arrays and stack applications. So here we again have expressions like postfix expressions, conversion from infix to postfix evaluation, all this problematic part we are going to see. So this is the one data structure stack we are going to discuss in our unit 1. And the next data structure we are going to discuss, that is queue. So here again we are going to see the queue operations and implementation of queue using arrays. And we have different types of queues, that is circular queues and priority queues. So we are going to see those implementations also. So today's topic, what we are going to discuss from our unit 1 is that one is introduction of data structures and its definition, abstract data type, and just I want to tell you what is an array data structure and the stack ADT, stack operations, and implementation of stack using arrays. So first let us see the definition of data structure. A data structure is a way of organizing the data and performing its operations efficiently. So we can organize the data in two ways. One is in linear manner and other one is in non-linear manner. So how we are organizing the data and what type of operations we are performing in this data is also important. So coming to the operations, we are going to do insertion, deletion, searching and sorting. So types of data structure. So this is the basic diagram of the types of data structure what we are going to see in complete our syllabus. So data structure, as I told you, that has been divided into two parts. One is linear data structure and non-linear data structure. So in linear data structure, we are going to see arrays, stacks, queues and linked list, where stacks and queues are going to come under unit 1 and linked list is going to come under your unit 2. Next, unit 3, we have this non-linear data structure, that is trees, and 4 is your graphs and tries. So let us see what is an abstract data type. Abstract data type is nothing but a composition of data and its operations. So what type of data we are taking and what type of operations we are performing on that. So the first data structure we are going to see, that is an array. So actually array we have seen in our C language. Here as in syllabus we don't have array, but we are implementing stack using arrays and queue implementation using arrays. So just I want to give a small definition of an array and let us see its implementation. So array is defined as a group of similar data elements. So here array we are going to have a collection of similar or homogeneous data type. So it is a static data structure. So it is not a dynamic data structure, it is a static data type structure. So coming to the declaration, we are going to have data type, array name and size. Example, if we take something int a of 5, where int tells the data type, a is an array name, so it is a user, again you can take anything, and 5 indicates the size, and always array is ended with a semicolon. So this is how I am going to represent it, and all the elements of the 5 elements in my array are going to be an integer data type. As we said that array is a collection of similar data types. So all the elements in an array, all the 5 elements are going to be the integer data type only. And here the array index is going to start from 0 to n minus 1. So example, let me explain the representation of an array. So as I told you that always the index number is going to start from 0. And here the elements 10, 20, 30, 40 are the elements which are holding the integer data type. And these are arranged in a collection of manner. And its memory location is also going to be continuous. So example, how it is going to be. As we know that integer is going to hold 2 bytes. So this is how it is going to have its memory location. It is going to be continuous. So this is about array, and the operations we are going to have same: creation, insertion, deletion and display. So next, coming to our major syllabus, we are going to have, that is stack. So let us see the definition of the stack and representation of the stack, and next we are going to see what are the operations it is going to perform and its implementation. So coming to the stack, a stack is a linear data structure where all the elements are inserted and deleted from one end, that is called as top. So let us see in the diagram. So this is a top. So from this one end only, we are going to insert the element and we are going to delete the element. So the insert operation, we call it as push, and deletion operation, we are going to call it as pop. So stack is going to follows a technique called as last in first out. So every element, as we told, that through top it is going to be inserted, and when we're coming to the deletion part, the last element which has been inserted is going to be popped out first. So pop out is nothing but we call it as delete, push is nothing but we call it as insert. So this is the diagram of the stack. So let us take the application of a stack in a real time. So example, I have a stack of books in this. So I have arranged the books in this as a stack. So which element is going to be deleted if I want to take one book? So the last inserted book is going to be deleted first. So this is how the real time of the stack works. So now let us see the operations what we are going to perform. So coming to the operations, we have push, pop, peek, display, is full, is empty. So already I have told you, push means nothing but to insert an element into the stack. Pop means to remove the element from the stack or delete the element from the stack. Peek means the topmost element of the stack is called as peek. Display means to print all the contents of the stack. Sometimes we call it as display or travel cell also. Is full. Is full means the stack is full. So no more elements can be inserted in this. Is empty. So the stack is said to be empty. So these are the operations we are going to see now. So coming to the stack implementation. Stack implementation can be done in two ways. One is using arrays and using linked list. So as still we have not discussed about the linked list, we have discussed about arrays. So in our unit 1, we are going to see the implementation using arrays only. So in the second unit, we are going to see this linked list. There we are going to discuss about what is a linked list and how again there we are going to see how the stack is going to be implemented using linked list. So coming to the stack using arrays. So stack using arrays. So as I told you that in stack, both push and pop operations are done through one end, that is called as top. Nothing but insertion and deletion are done only through one end, that is called as top. So let us take an example. First, let us discuss the procedure of push. So I'm just taking a stack size of 5 and initially the top is set to be 5. So example. So initially top is said to be -1. So now as I taken as the size, so size it starts again index number as if we are representing arrays, it is going to start with 0, 1, 2, 3, 4. So initially there is no element in the stack. So the stack is said to be empty here. Next, step 2. So we are discussing about the push operation. So I'm going to insert an element one after the other. something I have inserted a 10 element. So now my top has been incremented, means from -1 my top has come to top equal to 0. So top equal to 0 means 10 element is being inserted into the stack. Next, step 3. So again my top has been incremented from 0 to top equal to 1. So 20 element has been inserted. Next, step 4. So I have inserted one more element, that is 30. So now the top has been incremented to 2. Next, step 5. So top has been incremented to 3. So 40 element has been inserted. Next, step 6. Top has been incremented to 4. So 50 element has been inserted. Now, if I want to go for step 7, something if I am giving push again one more element into the stack, something 60. But here the condition is top greater than or equal to size -1. Means already I have taken my size as 5. So already it has full. So at this condition, top is said to be greater than or equal to size -1, and this condition is said to be overflow. So now I cannot insert the elements into the stack. So initially what we have taken, so initially my stack is empty. So that condition we call it as top equal to -1. So next I have incremented my top to 1 position. So top came to 0 position and 10 element has been inserted. Next, in step 3, top again incremented to the second position, 20 has been inserted. Again top has been incremented to next position, it came to 2, 30 element has been inserted. Again top has been incremented, top came to third position and 40 has been inserted. Again top has been incremented, 50 element has been inserted. At this time, again I have increased the top, but it cannot insert an element. Why? Because the size what we have taken, top greater than or equal to size -1, then stack is said to be overflow. At this condition, we cannot insert any more element into the stack because the size has been completed. So let us see the code. So this is the code for the push operation. So in if condition I have taken, if top greater than or equal to size -1, then stack is said to be overflow. In case if the else part, so in the else part we have written, so example, in the else part we have written, so just I have written and enter an value. So the element will be inserted into this. So when the top has been incremented, the stack of the top, that particular element will be inserted into the stack. So till when it is going to be inserted in this? Unless top greater than or equal to size -1, the stack will be, the top will be incremented and element will be inserted. But once top equal to size -1, no more element can be inserted into the stack, and we are going to print a message, stack is said to be overflow. Now let us see the procedure for the pop. So initially we have seen the insertion method. So pop is nothing but it is a deletion method. So here again step 1. So we are going to delete, it means stack is having some elements in this. So now initially top is set to be at 4 condition. So top equal to 4 means now what it is happening. So now I am going to decrement a top, nothing but top minus minus I am going to do. So at this condition what will be happening at step 2. So in my step 1, 50 element will be deleted from my stack. So how my stack is going to have 10, 20, 30, 40. So 50 element has been decremented and top came to equal to 3. So this is how. Again top minus minus. So what will be happening into the step 3? Again top will be decremented. 10, 20, 30. Top is said to be at 2. Means 40 element has been decremented. Next, step 4. Top is said to be at 1. So what it is happening? 30 element has been deleted. Next, step 5. Top is said to be equal to 0. Means what happened? 20 element has been deleted from the stack. Step 6. So when top came here, top equal to minus 1. It means the element which is in the stack has been deleted. Therefore, the stack is said to be underflow at this condition. So again let us see what we have done. So coming to the pop operation, that is the deletion operation. So deletion means I am going to delete an element from the stack. So the stack is said to be having some elements 10, 20, 30, 40, 50. So the top is said to be at 4. So now I am going to do top minus minus, nothing but decrement means one element will be deleted when top came to 3rd position. So the 50 element has been deleted from the stack. So coming to the step 2, again top has been decremented. So top came to the 2nd position, 40 element has been deleted. So again the top has been decremented to the 1. So the element in the 2nd position has been deleted, nothing but 30. Again top has been decremented to 0. So the 20 element has been deleted from the stack. Next, top is said to be equal to 0. So 10 element has been deleted. Now top came to 0, top equal to minus 1. At this condition, the stack is said to be underflow. It means we don't have any element to delete from the stack. So this is the pop operation. So now let us see the code. So coming to the code of the pop operation, nothing but deletion operation. As we told that here we are going to take an if condition, top equal to minus 1. It means there is no element in the stack. So we cannot delete any element in the stack. So we are going to write an printf statement, that is stack is underflow. Else part, now it will come here and it will be to the top equal to minus minus. So top equal to minus minus means the element which is at the in the stack will be deleted. Till when it is going to delete? Until the top comes to the condition top equal to minus minus 1. So that is the code of your pop operation. Next, coming to the display operation. Display operation means we want to display all the elements which are in the stack. So how we are going to do it? So the same thing. So if top equal to -1, the stack is said to be empty, means it doesn't consist of any elements, it will not display. So in case if not, I want to display all the contents. So this time I am writing a for loop. The condition is I equal to top, I greater than or equal to 0. That is I minus means the elements in the stack will be displayed. So as it is displaying the contents which are in the stack. So these are the main codes what we have, that is push code, nothing but that is insertion, and next pop, next display or travel cell. So these are the operations what we have discussed in the stack using arrays. So coming to the today's session, what we have discussed. So we have discussed about the introduction part in the DS and little bit the syllabus of unit 1, and majorly we have seen definition of DS, what is an array and its representation. Next, stack representation, real-time example. Next, we have seen stack operations, stack implementation using arrays. Not only arrays, we have seen the code also in depth, the code of push, pop and display. So these are the codes what we have seen, and next coming in this next session we are going to see stack applications, and we'll see expression, nothing but infix, prefix, postfix, and we are going to see its problems. We have some conversions, infix to postfix and postfix evaluation. These are the problems we have here in stack. So after that, then we'll go for the queue data structure. Thank you.